Trigonometric functions of any angle. So depending on the location of the terminal side of the angle, trigonometric functions can be positive or negative. So the signs of trig functions depend upon the quadrant that we are in. So let's say we are in quadrant 1. All of our trig function ratios are positive. Sine, cosine, tangent, all of them are positive. If we are in quadrant 2, the sine, cosecant, so this just is reciprocal, are positive, but all the others are negative. So cosine, secant, tangent, cotangent would all be negative. So it's the sine and its reciprocal cosecant that are positive in quadrant 2. When we get to quadrant 3, now it's the tangent and cotangent that are positive. All others are negative. So the sine and the cosecant, the cosine and the secant are all negative in quadrant 3. And then over here in quadrant 4, it's the cosine that's positive. So the cosine and secant are positive. All others negative. So the sine, the cosecant, the tangent, and the cotangent would all be negative in quadrant 4. And so we can use a mnemonic device or tool to help us remember this idea that in the first quadrant, everything's positive. In the second, it's the sine that's positive. In the third, it's the tangent that's positive. In the fourth, it's the cosine that's positive. The most popular one is all students take calculus, or you could come up with your own, but just somehow you have to remember that all of them are positive in quadrant 1, sine and cosecant in quadrant 2 are positive, tangent and cotangent are positive in quadrant 3, and cosine and secant are positive in quadrant 4. If the cosine of theta is greater than 0, which quadrants could the terminal side of the angle lie? Well, quadrant 1, because everything's positive there, or quadrant 4. You have to be over here to have a positive cosine. So either quadrant 1 or quadrant 4. And remember, we typically use Roman numerals to represent the quadrants. If the tangent is less than 0, which quadrants could the terminal angle of theta lie? So for the tangent to be negative, you'd have to be in quadrant 2 or quadrant 4, because here everything's positive and down here tangent's positive. So if we want it to be negative, it's one of these two quadrants. So either quadrant 2 or quadrant 4. If we want the secant to be negative, less than 0, which quadrants should it be in? So the secant is the reciprocal of the cosine. So we know that cosine and secant are positive here. Everything's positive here. So we'd have to be in one of these two quadrants for the secant to be negative. So either quadrant 2 or quadrant 3. If the cosine is positive but the sine is negative, okay, so for cosine to be positive, we have to be in quadrant 1 or quadrant 4. And if we want sine negative, we'd have to be down here. So it's got to be quadrant 4. If we want the tangent negative but the sine positive, we know sine is positive in these two. And if we want the tangent negative, it'd have to be this one, because over here everything's positive. So this is the only one in which sine is positive, but tangent would be negative. So quadrant 2. Number 6, if the secant is negative, so remember secant is the reciprocal of cosine, so we need a negative cosine, and the cosecant is positive, which is the reciprocal of sine, so we need negative cosine, positive sine. So that'd be quadrant 2. In here, we know the cosine and secant will be negative, but sine and cosecant are positive. So that's quadrant 2 again. All right, if the given is a point on the terminal side of an angle in standard position. Evaluate the 6 trigonometric functions of theta. All right, so if we are at 3, -4, that means 3. This point here is on the terminal side. And so here's theta prime that we're talking about. And so we can draw in our right triangle. This is 3, this is 4. And so if you know your Pythagorean triples, it's a 3, 4, 5 right triangle. If not, do Pythagorean theorem quick and figure out your hypotenuse is 5. So again, we're talking about theta right there. And so if I want the sine, it's always the side opposite the angle, so the side that's not touching the angle at all, not helping to form the angle. So this is the opposite side over the hypotenuse, which is always the longest side across from the right angle. So the sine of theta is 4/5. The cosine is adjacent over hypotenuse, so that's 3/5, and the tangent is opposite over adjacent, so 4/3. We know cosecant is just the reciprocal of the sine, secant is the reciprocal of the cosine, and cotangent is the reciprocal of the tangent. The thing that we have to consider, though, is the fact that this was -4. So these won't all be positive. Anything with that 4 in it should be negative. So the sine should really be -4/5. The tangent is really -4/3. The cosecant is -5/4, and the cotangent is -3/4, because this angle is in quadrant 4, and in quadrant 4, we know that the cosine is positive and the secant is positive, but everything else is negative. All right, another one. So we've got -5, 5. So if I draw this out on my Cartesian plane, so -5, +5. So we can draw in our right triangle here. So this is -5. This is +5. So this is a 45, 45, 90 right triangle, something isosceles. And so we know the hypotenuse is always the leg times the square root of 2. And the hypotenuse, that will always be a positive value. It will be these that could be positive or negative. And so we have our -5 here, +5 here, and then the hypotenuse is 5 square root of 2. So the sine, so here's theta. There's your reference angle. And so sine is always opposite over adjacent. And so we know it's going to be square root of 2/2 when it's rationalized. The cosine is going to be negative square root of 2/2 because we're in quadrant 2 and this value is negative. The tangent is going to be -1. So 5 divided by -5, -1. And then cosecant is just the reciprocal. So remember, to get the sine, we would have done 5/5 square root of 2. So the 5s would have divided out, and we'd have 1 over the square root of 2 that we rationalized to get square root of 2/2. So the reciprocal is really just square root of 2. And this would be negative square root of 2, and the reciprocal of -1 is still just -1. So what we see here, this is quadrant 2, and so the sine and the cosecant are positive. Everything else is negative. All right, number 9, given that the cosine is -1/3 and the angle lies in quadrant 2, find the remaining 5 trigonometric ratios or functions. So cosine is the adjacent side over the hypotenuse. So now we need the other leg. So 9 minus 1 squared, which would be 1, gives us 8. And if we square root that, we're going to get 2 square root of 2 for the other leg of this right triangle. We know it's positive because we're in quadrant 2. So the sine is going to be positive 2 square root of 2/3. The cosine is your -1/3 they gave us. The tangent would be -2 square root of 2 because we would have done opposite over adjacent, and 2 square root of 2 divided by -1 would be that. If we take the reciprocal, we'd have 3/2 times the square root of 2, but we'd have to rationalize and get 3 square root of 2/4. The secant will be -3, and the cotangent will be -1 over 2 square root of 2. But again, we would rationalize and get negative square root of 2 over 4, because we'd have the 2 on the outside times the other 2 once we rationalize it. All right, so this next one, tangent equals 2/3, and it lies in quadrant 3. So what this tells me is that the opposite side was 2, the adjacent side was 3, but they have to both be negative to be down there in quadrant 3. So Pythagorean theorem to find the length of the hypotenuse. So square root of 13 must be the length of the hypotenuse. And remember, here's theta. That's our reference angle. So sine is opposite over the hypotenuse, so we'd have -2 over the square root of 13, but we'd have to rationalize, so we get -2 times the square root of 13 over 13. Cosine would be -3 over the square root of 13, but again, we would rationalize and have -3 times the square root of 13 over 13. Tangent is opposite over adjacent, so that's where the positive 2/3 comes in they gave us. Cosecant, we take the reciprocal of the sine, so it's just negative square root of 13 over 2. Reciprocal of the cosine gives us secant, and then reciprocal of tangent gives us cotangent. So this one was in quadrant 3, where the tangent and cotangent are positive, everything else is negative. All right, using the given information, find the exact values of the trig functions for the indicated theta. So sine was 3 over 7. So we have this, so Pythagorean theorem to figure out the length of the other leg. So here's theta. The tangent is less than 0, meaning it's negative, so since the sine was positive, the cosine must be negative. The other leg there must be negative. We must have been in quadrant 2, and that's how I should have drawn it. We should have to be over here if we need a negative tangent, but a positive sine. So should have drawn it like this. You're over here in quadrant 2. All right, so the cosecant of theta is the reciprocal of the sine, so that'd be 7/3. And the cotangent here would be adjacent over the opposite side, so -2 times the square root of 10 over 3, since again, here's theta. All right, the secant is positive, that's the reciprocal of the cosine. So cosine's positive, sine is also positive. That means we're here in quadrant 1. So here's our right triangle. Again, secant is the reciprocal of cosine, so cosine of theta would have to be 1/3. So again, Pythagorean theorem to get the length of that other leg. So we're going to get 2 times the square root of 2. Again, all positive because we're here in quadrant 1. So cosine is 1/3, the reciprocal of the 3. The tangent opposite over adjacent will be 2 times the square root of 2. All right, cosecant is the reciprocal of sine. So sine is negative, and we know that the sine of theta would be -2 square root of 5 over 5 if we take the reciprocal of that and rationalize it. So sine is negative, cosine is also negative. We must be down in quadrant 3. So cosecant would be the hypotenuse over the opposite side. So this is -2. And then Pythagorean theorem, so we'd have 25 minus the 4 gives us 21. So this would be negative square root of 21 for the other side. Oh, oops, I did that. I forgot it was square root of 5. Let me try that again. If I square the square root of 5, I really just get 5. And then 2 squared would be 4. So 5 minus 4 gives me 1. Square root of 1 is 1 for the other side. But it would have to be negative since we are over here in quadrant 3. All right, now that I have the correct things for the side lengths, there's theta. So tangent is opposite over adjacent. So -2 over -1 will equal +2. Secant is the reciprocal of the cosine. So cosine is opposite over hypotenuse. So we're going to do hypotenuse over opposite. And so we'll get negative square root of 5 over 2. Oh, nope. That's not right. Cosine is not opposite. Cosine is adjacent. So cosine would have been negative 1 over the square root of 5. But we need the reciprocal of that, the secant. So we need hypotenuse over the adjacent side. So negative square root of 5. Sorry about the silly mistakes on this last one. Let's run through it again. So because we know that the cosecant is negative, cosecant is the reciprocal of sine, so it means that the sine is negative, cosine is also negative. So for both cosine and sine to be negative, we're down in quadrant 3. And so cosecant would be hypotenuse over the opposite side. So hypotenuse, opposite side. Then if I correctly do Pythagorean theorem, if I square the square root of 5, I get 5. If I square 2, I get 4. So the hypotenuse minus this leg squared gives us 1. The square root of that would give us the other leg. But because we're here in quadrant 3, the x values and the y values are negative. So this would have to be negative. So then tangent of my reference angle here is opposite over adjacent. So negative 2 divided by negative 1 is positive 2. Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. So for reciprocal, I need hypotenuse over adjacent. So we get negative square root of 5. And that's how we can find the exact values for trig ratios using this idea of where we are on the Cartesian plane and whether it's positive or negative for each trig ratio.